Dear students, in the previous episode, we discussed the topic solids and some related questions. I hope you have understood most of it, and today we shall have one more topic called solutions. In this topic, we can actually divide this chapter in 4 phases. First, the nature of the solutions and the way to express the concentrations. And in the second, we go for one of the typical solution system, that is the gas in liquid, and in second, it is the liquid in liquid, and the third, it is the solid in liquid. In these sections, we find the varieties of informations, like in the first, when the gas is dissolved in water, its solubility is controlled by the law called as Henry's law. When in the second, when two liquid components, pure components, when are mixed, their behavior is studied with the help of Raoult's law. And in the third, when the solid solute is dissolved in a solvent like water, the colligative properties will be taken up for the study. And these solutions also have some different characters, like the liquid-liquid system, where we speak about the ideal solutions, and non-ideal solutions. While in the solid and the liquid, that is solid dissolved in liquid, there we come with some of the characteristic properties, like the osmotic pressure, elevation in boiling point, depression in freezing point, and the relative lowering of vapor pressure. That way, we can have these properties. Out of that, as usual, as expected, we have some of the applications also. That's how we continue. And we continue with the sum of relevant questions pertaining to these 4 different phases. In the first, if we are to know about the concentration, what is meant by concentration? It is nothing but a definite amount of the solute present in a specified amount of the solvent or specified volume of the solution. Thereby, how much solute is present in how much solution, or how much solute is present with how much solvent. It is expressed with the concentration terms. In this topic, we are mainly concerned with the 3 concentration terms called number 1, molarity, and number 2, molality, and number 3, mole fraction. Dear friends, in the previous episode, we took up the solids and the sum of the concerned and related examples, and try to understand how these questions appear and how they can be approached. Today, we shall select one more topic, the topic solutions. And in this chapter, we mainly find the four phases where the discussions are separated. In the first, we deal with the solutions in general with respect to their concentration terms. In the second, we have one type of the solution where the gas is supposed to be dissolved in a solvent like water, and there a solution is formed. And with this solution, we come with the Henry's law, and in this Henry's law, we have some practical applications. In the second, we prepare the solution using the two liquid components, liquid-liquid system, and in this solution, we have one more new information, ideal and non-ideal solutions. And in the third, it will be the solute, the solid, dissolved in the liquid solvent. There we get the colligative properties, and these colligative properties like relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and the osmotic pressure, and some of the applications derived out of these properties. And these four different phases require some of the related examples, and with the examples, here we have the first of the question: which of the following concentration terms is supposed to be temperature independent? The three terms that we see here are the molality, then the molarity, and the mole fraction. And about the three, what is the difference? In case of the molarity, the commonly used concentration term in the laboratory, we speak of the volume of the solution, while in molality, we speak of the weight of the solvent. And in mole fraction, of course, it is the mass quantities used to get the mole fraction. We have here, one is the volume related term, molarity, while other two are the mass related. And we know the volume is always susceptible to temperature. As the volume changes, it is because of the temperature effect here. Hence, the independent properties, temperature independent properties should have the mass quantity, and that we see in the molality and mole fraction. Therefore, the first option you need not or you should not mark it because it is only molality. No, it is molality and mole fraction. Therefore, option D is correct. Molality and mole fraction, which are not at all related to volume, are temperature independent that way.